The algorithmic complexity of this problem is increased because Google Maps need to perform these calculations on a large scale, converting an extensive network of nodes and edges. Not only does the algorithm have to run efficiently over a vast data set, but also has to incorporate real time data. Hello, all. Welcome back to Being Passionate Learner. I'm Dr. Padmapani Tribhuvan. This is first lecture on algorithms. So I welcome you to the Design and Analysis of Algorithms series. In this series, we will explore the fascinating world of algorithms, diving into how they shape this digital world around us, from sorting and searching to dynamic programming and graph theory. Algorithms power everything from search engines to social media, and mastering them is essential for anyone looking to deepen their programming and problem solving skills. Throughout this series, we will break down complex concepts into simple. We will discuss examples, practicals, and insight from the book Introduction to Algorithms by Corman. Whether you are a student, professional, or tech enthusiast, this series will be guiding you for understanding and designing efficient algorithms. So, subscribe and let's get started on this journey into the heart of computer science. In this video, we will focus on understanding what algorithms are, why they are so fundamental, and explore some of their real world applications. We will be referring to two main resources: Introduction to Algorithms by Corman and Algorithm Design and Analysis by Udit Agarwal. Here is an overview of this video. We will start by defining what algorithms are and why they are essential. Then we will discuss characteristics of good algorithms, followed by an introduction to algorithm complexity. Next, we will explore some key applications and design strategies, including case study on Google Maps, and we will also cover real world uses and ethical considerations. Let us start with what is an algorithm. An algorithm is essentially a set of steps designed to accomplish a specific task. It's important that an algorithm is finite, clearly defined, and generates a result. Some everyday examples include sorting a list, finding the shortest path between locations. Why study algorithms? Algorithms form the foundation of computer science. By studying them, we learn how to solve problems efficiently and effectively. Algorithms optimizes time as well as resources like computer memory. A good algorithm can drastically improve the speed and the scalability of a system, which is crucial when working with large data sets. Characteristics of a good algorithm. A good algorithm is not just about getting the job done, it should be correct, efficient, simple, and robust. This means it should always produce the right result, use resources wisely, be straightforward to understand, and handle unexpected inputs. Algorithm complexity. Algorithm complexity gives us a framework to evaluate an algorithm's efficiency. Time complexity measures how runtime changes with input size, and space complexity measures memory use. Big O notation is commonly used to express these complexities. Basic algorithm applications. Algorithms are applied across different problem types. Sorting and searching algorithms. These algorithms organize and locate data efficiently. Graph algorithms are used to navigate and networking. Optimal algorithms find solutions that minimize or maximize specific criteria. Let's take Google Maps as a case study. Google Maps is an excellent example of how algorithms are used to solve complex real time problems, specifically for finding the shortest and fastest route. The primary challenge for Google Map is to provide the shortest and most efficient route from one location to another. Users need a route that minimizes travel time and distance, which becomes even more complex when factors like traffic conditions, road closures, and detours are considered. Algorithm. To find the shortest path between locations on map, Google Maps uses a modified form of Dijkstra's algorithm. Dijkstra's algorithm is designed to calculate the shortest path from a starting point to a destination point across a graph, where the graph represents the location as the nodes and the roads as edges. The algorithm works by exploring all possible paths from the starting node and calculating the cumulative distance until it reaches the destination, choosing the path with the smallest total distance. The algorithmic complexity of this problem is increased because Google Maps need to perform these calculations on a large scale, converting an extensive network of nodes and edges. Not only does the algorithm have to run efficiently over a vast data set, but also has to incorporate real time data such as live traffic updates, road closures, and user reported incidents. This requires both computational efficiency and effective data processing deliver fast and accurate results. This example highlights how algorithms are not just theoretical constructs but powerful tools that shape our everyday lives. Algorithm analysis framework. Analyzing algorithms involve four steps: problem definition, algorithm design, complexity analysis, and implementation and testing. First step is defining the problem. In this step, we try to understand the requirements and constraints of a problem. Second step is designing the algorithm. In this step, we choose a strategy, for example, divide and conquer, greedy, dynamic programming, etc. Third step is analyzing its complexity. In this step, we evaluate time and the space complexity of a selected strategy or algorithm. And last step is implementing and testing. In this step, we code, test, and refine the solution. This framework helps in creating algorithms that are both effective and efficient. Now let's see some common strategies for designing algorithms. Divide and conquer is useful for tasks like sorting, for example, merge sort. Greedy algorithms work well for tasks like minimum spanning trees. Dynamic programming is efficient for problems with overlapping subproblems, for example, Fibonacci sequence. Backtracking helps in exhaustive search, it explores all possibilities. As per our requirement, we select any one of these strategies for designing our algorithm. Now let's see some real-world applications of algorithms. Algorithms have real-world applications in diverse fields. Data compression algorithms like Huffman coding reduces storage needs. Machine learning algorithms enable artificial intelligence. Machine learning algorithms enable predictive modeling, for example, neural networks. And cryptographic algorithms secure our online communications. Now let's see ethical consideration. While algorithms have vast potential, ethical considerations are crucial. Algorithms can unintentionally propagate bias or violate privacy, especially when handling sensitive data. It's important to maintain accountability in algorithm based decision making. To conclude, in this video, we have covered the basics of algorithm, what are they, why they matter, and some typical applications. We also discussed ethical concerns as algorithms increasingly impact our lives. Understanding these concepts will be foundational for our journey into more advanced algorithm topics. Thank you for watching this video till end. See you in my next video. Till then, being passionate learner, keep learning. Thank you.